Welcome to this .NET MAUI Autocomplete tutorial. In this video, I will demonstrate how to integrate AI-based searching and customize the filtering process to achieve accurate results, even when there are no exact matches in the Syncfusion .NET MAUI Autocomplete. First, I open an existing MAUI application. I've already configured the .NET MAUI Autocomplete control and specified a source path for displaying country names. I have also set up the .NET MAUI text input layout to display hint text that appears as a label above the input field when the user starts typing. To learn how to add the .NET MAUI Autocomplete control to your MAUI application, watch the video linked in the YouTube card above and the description below. Now, I'll run the application. Once the application is loaded, I enter a character in the input field. You will see the items that start with the entered input displayed in the drop-down box. Next, I will show you how to display accurate results in the autocomplete control, even when there is no exact match. I will begin by integrating an AI service into the application. So, I open the project file and add the Azure AI OpenAI package. In this example, I've chosen Azure OpenAI. However, you can choose any chat completion service. If you decide to use Azure OpenAI, make sure that you have access and have configured deployment through the Azure portal. Once the package is added, I create a class called Azure OpenAI Service to handle interactions with Azure OpenAI. I begin by declaring three constants: endpoint, which specifies the Azure endpoint URL for API calls; deployment name, which refers to the name of the AI model; and key, which is the API key for authentication. These values are essential for connecting to Azure OpenAI. Next, I declare two private fields: client of type OpenAI client, which manages communication with Azure OpenAI, and chat completions, which stores chat request options such as filtering rules. To set up the OpenAI chat service, I create the initialize chat completions method and call it in the constructor. In this method, first I initialize the OpenAI client to authenticate and interact with Azure OpenAI's API. Next, I create an instance of chat completions options to configure the AI's response. This object holds all the settings that define how OpenAI should generate responses. I specify which AI model should be used, and then assign a value to the temperature to control the randomness of the responses. Next, I specify a value for max tokens to limit the number of words in the AI response. Nucleus sampling factor to control how many words the AI considers when generating a response. Frequency penalty to reduce the probability of AI repeating words. And presence penalty to encourage the AI to introduce new words rather than using the same ones repeatedly. Then, I create an instance of chat request system message to ensure the AI follows specific filtering rules and add it to the message property of the chat completions object. Similarly, I create an instance of chat request user message, which provides detailed instructions to guide AI in following specific filtering rules. Additionally, I create an instance of chat request assistant message, which contains sample output to help the AI understand the expected formatting. Next, I create the getCompletion method to send user prompts to the AI and retrieve responses. In this method, first I check whether the chat completions and client are not null. Then, check if the message history exceeds 5 tokens, and remove the older messages to keep only the most recent ones. I add the user's prompt to the chat history, allowing the AI to process the latest input. Within the try block, I call the getChatCompletionsAsync method to fetch responses. I remove any extra spaces to ensure a clean output, and the response is added back to the chat history. To prevent crashes, I use the catch block to handle API failures and general errors. Finally, if an error occurs, I return an empty string instead of allowing the program to crash. To filter a list of countries using Azure OpenAI, I create the country filter behavior class that implements the autocomplete filter behavior interface. This includes handling typos and phonetic similarities. I create an instance of the Azure OpenAI service class, which was defined earlier, to manage communication with Azure OpenAI for generating filtered results. I define a property to hold the list of country names. and another property to store the filtered items after processing user input. Within the constructor, I initialize the Azure AI service and the countries collection. To filter the items using Azure OpenAI, I create the filter countries using Azure AI method. In this method, first, I ensure that the filtering logic is executed only if the user input is not null or empty. Next, I formulate detailed instructions, specifying rules for filtering such as phonetic matching, case insensitivity, and typo tolerance. I also instruct it to return only valid matches. Additionally, I include the user input, the list of items, and an output template as a sample format for the AI's response. I use the getCompletion method to send the request to Azure OpenAI to process and retrieve the filtered results as a string. When the response is generated, I split it by new lines, remove any extra spaces, and create a clean list of country names. Next, I check whether the filtered countries collection contains any data. If it does, I clear the existing data to prepare for the new filtered results. Then, I check if the AI response is not empty, and iterate through filtered country names, adding each country to the filtered countries list. Finally, return the filtered list to be displayed in the autocomplete component. To filter items based on user input, I proceed with the getMatchingItemsAsync method. In this method, I retrieve the list of countries and store it in the countries collection. Next, I concatenate the names of all countries in the countries collection into a single string, with each name separated by commas. This string is then passed to Azure OpenAI as part of the filtering prompt. Next, create a sample output structure by joining the names of the first 5 countries with new line characters. This structure will serve as a reference format in the prompt sent to Azure OpenAI. Then I call the filter countries using Azure AI method to send the user input, the list of countries, and the reference output template. Finally, return the filtered countries as the output. To configure the custom filtering behavior, I navigate to the main page XAML. Within the autocomplete control, I define the filter behavior property and add the country filter behavior class using the local namespace. Once done, I run the application. As I type characters in the input field, you'll see that the drop-down menu displays suggestions even if there is no exact match. Let me wrap up this video. You have learned how to integrate AI-based searching and customize the filtering to achieve accurate results, even when there are no exact matches in the Syncfusion .NET MAUI Autocomplete. If you would like to see the working code for this example, download it from the GitHub link in the description below. I have also included a link where you can check if you qualify for our community license, which provides you with a free license key for all our .NET MAUI controls. If you found this video helpful, click the like button and subscribe to our channel to watch more videos like this. Thanks for watching.